I'd like to start off today. This is going to be a talk about security, but I'm going to look at it from a slightly different perspective. It will be technical a little bit, but I'm talking more about an overall objective. Now, before I got into the information security space, I was a software developer. I wrote kernel code, device drivers, a number of applications for a variety of operating systems, including the Unix space, and this was even before Linux. My work started off in NASA at Cape Canaveral, and it was there where I really got an understanding of what software development or secure software development really means. And a lot of people think about secure software development simply as sanitization or preventing buffer overflows or some context like that, but in my opinion, it's actually a larger issue. In the concept of true risk management from a software perspective, your code, the code that you wrote today and that it's just went out to production, if you look at it from code A, 5 years from now, it's going to be most likely a completely different animal. Now, take a look at the iPad, for example. Back when it was released, I think in 2007, there was all this chatter that Steve Jobs did not want a stylus. He did not want to use a stylus. So what did Apple do today? They made a stylus, and it became a controversial issue. In reality, though, Apple released it because their customers were saying, or especially the artists, we would love to have a stylus to draw on it. Customers use the iPad in ways that even Apple didn't dream of. So Apple decided to satisfy their customer needs and implement a solution. They saw a market, they took advantage of it. Now that's great from a business perspective. You're in software development, you've got to worry about the code you write and that it's going to be changed over time. So you've got to have the foresight to know that what is unexpected and to be able to make the appropriate changes without breaking your back or breaking your company or causing so much havoc. And I'm going to use an actual example from my personal experience. So let's start off with the concept of flexibility in this context. And it just simply means to be able to modify code within a reasonable perspective to maintain a secure state. Now, in older versions, it was more quality. But we're not just talking about today about buffer overflows or cross-site scripting or anything like that. The fact is you've got to write code today, as I showed you in that previous page, that what you're probably going to expect 5 years from now is almost completely different. And there are a number of outside influences on this. There could be, oops, excuse me, I've got to go back. Come on. I jumped the gun on that. You can have customer requirements. You can have competition. You can have regulatory issues such as PCI. If you've ever written software that is for PCI use, you know that PCI changes their requirements. And auditors often change their requirements within the PCI space. So you've got to have the foresight to expect what I'm writing now is not going to be acceptable 5 years from now. I've got to be a little willing to make changes. You have competition that might make code better than you and more secure than you. Now, since you just walked in the room, I'm going to plug Claire for a minute. And I'm going to use Claire as an excellent example. Claire gave a great presentation on two-factor authentication, especially like through biometrics. You write code today because your boss wants fingerprint authentication. In comes Claire into your business. Now, if I saw Claire walking into my office or my complex, it all depends on what the situation is. If she's professionally dressed and talking to my CEO, guess what I'm going to be doing? I'm going to be modifying code because the boss who screamed at me saying, why aren't you doing this, is now going to change his mind and say, you need to change it. Now, if Claire is more casually dressed wearing jeans and wandering around the back, then I really get scared because she's up to no good for good reasons. And as the old saying goes, Claire's opinions on authentication carry a lot of weight. around here. I just carry a lot of weight, period. Okay? So now that we have that, so let's say, for example, you have to worry about authentication. Claire comes in and tells your boss, you're doing it all wrong. Guess who your boss is going to see next? And guess what he's going to demand? So if you have, in the initial design, thought about that anticipation and thought about the concept, you're going to be changing your code over time, it can make a difference between doing it right and making it fast and good while maintaining a secure state, or rushing it from the very beginning and doing it wrong, which turns out to be a major hassle. I'll give you a couple examples. You know SSL is being phased out. Well, somebody has to use SSL, or somebody used to use SSL. Now it's going to TLS. And now it's not even a PCI requirement anymore. If you're using SSL in your code, you are not PCI compliant. It was effective last June. MD5, now I'm having, as soon as Claire shows up, now my stuff starts breaking. Okay, so TLS is the same thing. But I'm going to continue as it was. But there's one other factor that a lot of people don't talk about: your career. I've been around long enough to know how to move and improve your career. A lot of developers make the mistake of not really understanding what their work can do in the long run. If you are expected to change your job within the next 5 years. Good software development means if you can write code better than your coworkers, that is easier to change, less time to modify, and more secure, and you have the metrics to show it, or at least reasonable metrics to show what you can do, you are the one who's going to be hired over your competitors. Or in fact, if all of you in here are vying for the same job, and you did it better than everybody else, and you have reasonable amount that you can show it, I, as the boss, am going to hire him. All of you are just going to be ambiguous. Oh, yes, I write secure code. Big frickin' deal. Everybody writes secure code. But you wrote code that reduced the known vulnerability rate and reduced errors in your testing by 30%. And the changes you made line by line were faster by 2 weeks than your coworkers. That's what people want to see. And I'm actually going to focus on your career a little bit, because a lot of you are probably going to want to change jobs over time. Okay? So when you look at the concept of flexibility as the way it works into security, it really works very well. It may not look like it from the very beginning. In fact, there's going to be extra work in the beginning. But study after study after study after study have all concluded the same thing. If you design it right from the very beginning, it may be the most hassle at the start, but over time, it is easier to implement, easier to change. Your boss is going to scream at you probably why you aren't done with your code, why it's taking you so long. But that very same boss, if you have to make any changes, is going to scream at you 6 months later, screaming, why hasn't the changes been implemented yet? So you, as a software developer, if you really want to get into the security space, it's more than just thinking of buffer overflows or anything like that. You've got to look long-term, plan ahead, think about what changes can be made, and how you can design your architecture so that those changes can be easily implemented. If you look at architecture from any other perspective, from the physical world, whether it's airline, structures like bridges or towers, or anything, even ships, any good engineer has the concept to understand that that structure that he or she builds is going to be subject to change due to nature's effects. Skyscrapers do not, believe it or not, are not that rigid. They bend with the wind. You may not tell it, but they do, because a good engineer knows that they can only resist outside changes so much. Bridges will be built with the anticipation that the ground below it will change. So they design it with that change in mind. There was an article maybe about 10 years ago. An engineer was flying with a 7-year-old son, and they were experiencing some some medium turbulence. The son was terrified, being 7. He said, Dad, the wings are going to fall off because they were bouncing like this in the turbulence. The dad said, no, you should be happy they're like that. They're not fighting against nature. It's bending along with it, and because it's flexible enough, being aluminum is so low density, it is able to adjust accordingly and rather snap off. It's able to adjust with the current environment and go on. That's one of the reasons why the Titanic broke, because the metal was so rigid and so inflexible, the weight just eventually sheared the ship off. When you take a twig, for example, a healthy young twig, you bend it, it will be flexible. When you take an old twig, it breaks. Same concept. So there are a lot of advantages to flexibility, but there are some disadvantages. And I've listed some of them here, okay? You will impact your performance a little bit, but it's not that much as it used to be. In other words, because of processing speed and compiler optimization, it has reduced somewhat. You've got to think of your integrity, because you are probably going to have to change your internal structure or your internal data elements as you go along. So you've got to focus that into consideration. So there are some general disadvantages, but overall, if you plan it well, you can design something really well, so that when your boss comes to you and say, we need to make this change, you can make that change. And I'm not talking about a minor change. I'm talking about a comprehensive major change, which I will show in a moment. Now, the concept of flexibility is not new. It was actually thought about back in 1977. And I have references at the end of this talk, and this will be available to the public, okay? It was from Griffith Air Force Base and General Electric, where they wanted to improve the quality of their software development in the military. Flexibility was one of the top 11 out of 55 requirements for their design. And flexibility breaks down even to further, such as accessibility, adaptability, and so forth, okay? Flexibility is not just whether you can expand your buffer to accept a larger string, but your customer is using your software right now. What are you designing in it so that if you have to make a change to expand that buffer, what are you doing so that it doesn't impact your customer? Are you designing it in a way so that if you think, if I have to increase that buffer size, is it going to impact my customer? If it will, what does my customer have to do to make the change? So you've got to think of something like that, right? You've got to think of something like that too. And unfortunately, in my opinion, software engineering is becoming a lost art. I attended a threat analysis class at Black Hat last year, and I was the only one over 35, and they were including 3 software developers, and none of them could do reverse engineering. None of them could read assembler. None of them could even understand the basic concept of the stack. None of them even had a basic understanding of what registers do. If you are going to be a good software engineer and really excel, you need, just like any other engineer has to understand the environment which he or she works on. If you're building a bridge, if you're dealing with high-level water or high-velocity water, you've got to think about that. If you're building an airplane, you've got to think about the stress factors involved. Software engineering is becoming nothing more than just a buzzword. I'm a software engineer. I write in Java and PHP. Whoop-de-frickin-do. Okay? I used to write an assembler. I had to debug an assembler. And I hated it in the beginning. But you really understand the architecture. If you don't know the architecture which you're building on, fine, that's one thing. But don't call yourself a software engineer. You're a programmer. You may be good at what you do, but if you're going to go into device drivers, if you're going to go into kernels, if you're going to go into low-level security, if you want to reverse engineer, you've got to understand it. Because whatever you write, I can break. I can go in with a kernel debugger and modify your code, change values, and make it work the way I want. So you've got to think about that. And we need these type of people. We don't just need PHP programmers, nothing against PHP or Java. But we need people who really understand the architecture. I've seen a lot of crappy code by so-called programmers who write it in this static viewpoint But when things have to change, it all becomes a major undertaking, and a lot of things break. The paper that I just talked about, it's just like every other report. The longer you wait to really implement good software design, be flexible enough with change, the more expensive it becomes over time. Doing it from the very beginning is best. But you're going to run into a lot of business resistance. You're going to want your boss is going to want to be the first on the market. The next boss who tells me that he wants to be first, I swear I'm going to hit him. I mean it. I am sick and tired. Oh, we want to be first on the market. So what? How many times have you probably heard of a news article that we were first to report it? Yeah, they were all wrong. Okay? Is your objective to satisfy your customer needs, to be secure, or is it first to say you were first on the market? Great, you were first on the market, but your code sucks. I broke it, everybody breaks it. And now it's on the wall of shame in every hacking website known to man. Okay? Sometimes first is not always best. Another concept, we'll sell it now and we'll fix it later. A lot of managers make the mistake of architecture being something like, oh, we'll just flip the switch later. Okay, why don't you just flip the switch now? When you build a house, you design your windows, you design your electrical systems, you design your lighting while it's on the paper with your architect. You don't build it 80% done and then say, oh, I want to change this, I want to change this, I want to change this. Your architecture will hit you. Why? Because there are stress factors involved when building a house. You design it on paper and then build it. Same thing with software design. It's no different. The processes may be different, but you've got to go with the same general concept. A lot of managers think we'll flip a switch, we'll change a value, and it's done. The very first question I ask that boss, do it now. What's the big deal? And they later find out it's not as easy as it sounds. They're quick, they want to be out, we'll fix it later. But think about it, your help desk will have higher costs. It will probably cost more to implement good software development in the longer run. When OS2 was released, and I'm going to go into OS2 in a minute, IBM had to hire a lot of help desk people and had to get software developers to do a lot of the help desk, including me, because it had so much problems in the beginning. Same thing with your code. You may think it's great, we're first on the market, we're out, but there are impacts. You don't want angry customers calling you. Limited budgets. If you're releasing a product that's for PCI or HIPAA, and I think Claire knows what I'm talking about on HIPAA, is if it is not right or if it's poorly made, the regulators are going to be coming after you, and you do not want that. Trust me on that. You do not want that. Your business is going to, you may have a bunch of risks that you understand what are going on with your code. Your business, however, has 4 general types of business risk, and I've listed them all there. If you need to communicate an issue to your boss, you can talk about technology all day. He's not going to care. He wants one of these 4 types of risks that's going to impact him. If you can address why you need to do a better job, and if you can address one of these 4 issues, you are more likely going to get your boss to change his mind. Don't even bother talking about technology. He's not going to care. They have to run a business. You need customers in order to get money. You need a paycheck, don't you? And don't tell me that you're a secure software development company, because security does not sell. Products and services do. So you've got to think about that. If you sell security and your reputation is impacted or your liability is going to go up, then your boss is going to start seeing your point of view. Okay? So now I was talking about the architecture. I'm going to go a little bit about what it's been like in the past. And there's a reason for this. Obviously, you can see the table on here of the number of bits for each microprocessor. In the old days, I know I'm going back, I'm dating myself, but we used to have to deal with near and far pointers and that type of thing. For complex mathematical operations, we had to go into special assembler routines in order to do that because the 16-bit architecture alone just did not have the capability. So when you are writing your code, you may think, okay, we're fine. It's running fine. We don't have any problems. Now, when we did OS 2, the original 1.0 version of OS 2 was 16-bit. Now we're going to 2.0. And IBM just said, hey, we've got these new machines. Let's make them 32-bit. Oh, that sounds great. Except that there was a lot of impact from the 32-bit perspective. And I have one example. For example, a lot of developers used to write if they wanted to start off with -1, even if it's an unsigned integer. In C, you can do FFFF. That's fine. But what happens from the 16 to the 32-bit? Look what happens. Because an integer is implementation dependent. It is not a fixed 16-bit value. It changes with the microprocessor. So if you have FFFF, this is what it becomes. It is now a different value. But if you maintain the -1, the unsigned integer -1, it changes, and when it goes eventually to 128-bit, it will change as well. Because a compiler, they're smart enough, even in the old compilers, they will automatically change. If you did it the old-fashioned way, you have to go into your code now and make changes. If you did it this way, even as an unsigned integer, you don't have to worry about it. You just saved yourself some time. You had made your code a little bit more secure. And your boss may be a little bit happy to find out it took you days rather than weeks to make the change. This is what I'm talking about. This is just the beginning. We're talking about pointers. You can talk about between ASCII and Unicode. Rather than strict ASCII strings, what about Unicode strings? You're going more international. You got to worry about that. And you may think, okay, I write in Java. Whoop-de-frickin-do again. I used to write the Java runtime compiler in the AIX operating system. That was written in C. And I am surprised we had it running. Because even if the AIX operating system changed, it could impact the Java runtime environment. So don't think because you run Java, you're secure, you're safe, everything's fine. No, you're running Java on top of another library, which is running on top of your operating system. And that library runs C and assembler. And AIX is not an Intel-based system. It is a Power-based system, which uses an entirely different architecture. It's not just four general-purpose registers. We're talking like 16 general-purpose registers. It's an entirely different animal altogether. Apple used to be a Power environment. They moved over to an Intel environment. That was a complex, long, and costly change, which impacted Apple, but they eventually got it right. So as you probably noticed, I'm going to be talking about OS 2 a little bit. And I worked on the OS 2 operating system for a number of years, all the way back from the 1.0 days. And I'm going to go over one specific component that I worked on with OS 2. And this was from 1.0 to 2.0 and later to 2.1. Now, this does not impact security per se, but this does impact data integrity. And this was the OS 2 PostScript driver. What you're looking at on the screen is a visual representation of what the old OS 2 PostScript driver did. We supported printers. That's it. We did our little thing. We printed duplex or we used color if it supported, that type of thing. No big deal. So we had but there was a little bit of a problem. Number one, we had to go to 32-bit, so we had to fix all that first, and that was a complicated mess. Because a lot of the coders weren't thinking long-term, they were just thinking very short-term. If I needed -1, and believe it or not, 0 can be a valid value. If you're dealing with age, 0 can be a newborn. That is a valid age. So you might want to use -1 as an uninitialized value. So what was happening was, aside from IBM, printer manufacturers were coming out with these brand new, gigantic, multi-function, multi-power printers that could do everything except make coffee. And so at that time when I was working on the OS 2 PostScript driver, my manager and his leader said, run simple rule. If you're not backward compatible with OS 2.10, don't bother coming into work again. You've got to be backward compatible. This was the old version. Then what was happening is, that was prime directive number 1. Prime directive number 2 is this was at the time when OS 2 was going directly head-to-head with Microsoft. Remember NT? OS 2 wanted to compete with Microsoft head-to-head, and prime directive number 2 is make OS 2 as usable and flexible and powerful as possible so that as many people can buy it as they want. So what was happening, I have management here telling me one thing, I have the OS 2 vendors like the printers telling me another, and I'm sort of caught between. And I think I screamed a lot like that. I have the sound turned off, but I think I screamed a lot like that during my development days, okay? I actually had to get the printer manufacturers to come and help me out, going to IBM management to say that they wanted this feature, and they threatened IBM saying, if you do not add these new features, we're dropping you. In other words, that's it. Now think about that for a second. You've written this code, and you have these current security features, let's say SSL. But now everybody's saying you've got to be TLS. And if you don't implement TLS, we're dropping you. Now you can say, wait a minute, we're fine as it is, it's not going to be a big deal. No, you need your customers for support. So what are you going to do to make the change quite easily? Well, in this case, it wasn't easy. It was difficult. No, correct, it was extremely difficult. Because I had to maintain the backward compatibility for 1.0. I had to be forward compatible with these new printers. And to make things even worse, some person in IBM decided to let some vendors allow them to directly modify specific printer features by themselves, like Alder's PageMaker. So I had to focus on that as well. And then to make things a little bit better, I was moving from Boca Raton to Austin. Okay? And so thanks to this, I missed a great fishing trip, and I missed a great shrimping expedition because I really wanted to do that when I got to Mobile. So here was the new one that we finally came out. Very complicated. There were a lot of failures. There were times I didn't think it was going to work. This page right here would change with each printer manufacturer. We finally got it to a way where everybody was happy. If we were to manage it ourselves, the data segment would grow exponentially. Imagine 255 printers, each with 4 or 5 of their own features, and maybe a later version could add another 4 or 5 features. Do the math. You'll see what I mean. But what we did here is we let the printer manufacturers, you just make a selection. You don't care what it is. The printer manufacturer will send the appropriate command. And in order to make things a little bit worse, you can't really tell, but skip that last one. That could be something like, well, you want duplex, but what if you have a transparency? You don't want duplex with a transparency, so you have to turn this off. So we have to add that in too. Now, in all reality, this was not IBM's fault, seriously. Because when they originally designed it, they never anticipated this to happen. They just anticipated, we just want to make a simple print driver. It was the printer manufacturers who had all these they had their own ideas. They wanted their own support. The bankers wanted the old version of OS 2. So as I showed in my previous slide, you can see all these outside forces that are coming in and stepping on you and telling you, we want this, we want that, we want it now. And guess who your boss is coming to? So what do you do as far as thinking from a more flexible and more encapsulated perspective, thinking about that long term? Well, going to the standards section is obviously design a framework, and you can use something like agile methodology. Now, some companies still use waterfall. More companies are going to agile, and I'm going to go a little bit more into agile in a minute. Encapsulation is important. Encapsulation is not only great from a object-oriented perspective, but it's also great from a C perspective. You can do good encapsulation from a C perspective. minimizing your global variables, because your customers are going to take advantage of whatever opportunity you give them. Whether you give it to them or not, they will take advantage of it. You want to design something where, say, I know I'm going to have to make changes, so what do I have to do from the very beginning to permit those changes? I don't know what those changes are, but is there something that I can do that makes those changes possible? In the OS2 example, what I did was use a very primitive version of XML. I allowed multiple selections, various multiple data links, and sent it across the network. And I also updated the old version, and I had to make sure that both were working fine. So even as these new printers grew, it didn't make any difference. It was flexible enough where you could just add the new feature that you wanted, and it would just work as is. And we would grow the buffer accordingly. It was a very tedious, complicated procedure, but it finally got to work. We want to rely on polymorphism, on common interfaces. A lot of people think, well, I'm going to rely on this interface for this and this interface for that. What we did with OS2 is we relied on one common interface for all the drivers. We actually simplified things. And if you were a printer manufacturer, you want to add your own special features, we enabled that very easily. By designing that in from the very beginning, it became so easy for people to add new features. HP, for example, wanted special color support. Tektronix wanted their own unique way of handling their output. And we were able to give it to them. Now, again, this is not dealing with security per se. It was more of integrity. But you can see what I mean, that when all these outside forces come in and expect you to make changes, are you going to be ready for those changes? If Claire comes walking in your door and says your two-factor authentication doesn't work, and you're using RSA, how easy it is for you to move to the Gemalto model of two-factor authentication? Your boss is going to want it now. No, he wants it yesterday. And he wants it cheap, and he wants it done professionally. And he's going to tell you everything. You've got to make that work. So if you design it right from the very beginning, saying, knowing full well, I might have to change this. So what do I have to do to make it portable and encapsulated and be modular so that I can easily go from point A to point B? This may seem obvious to most of you, but believe it or not, I come up to this a lot, especially with the younger developers. They create something and they don't bother to initialize it, or they don't bother to set default values. And then, like right up here on the third bullet point, setting all variables to a non-defined or not to use state. I come across this a lot. They define something and they forget to initialize it appropriately, both in creating and removing. Now let's make one point clear. I can go in and modify anybody's code here. I can go in and modify the kernel. I can go in and do a lot of things. There's only so much you can do. But the one mistake a lot of software developers make, they think that attackers are all experts. They think they're all godlike and they can do all these wonderful things. A lot of attackers are idiots, okay? I may not be smart enough to modify your fingerprint, but it doesn't take a rocket scientist to see what you were doing with your 4-digit code as you were entering on the phone. I was in Singapore one time, and I had lost count because every single time when I would go on the train to work and from work, I caught no less than 5 people entering their 4-digit passcodes in front of me. I can just steal their phone. I don't need any technical expertise. I steal your phone, I remember your 4-digit passcode, I'm in. So when a lot of people often forget that part. They forget to initialize variables at the very beginning, and they forget to reset it to a non-use state at the end. That's important because when you free memory, if you're freeing it from the heap, that's out of your control now. But it's not out of the operating system's control. It's not out of somebody else's control. It is just out of your control. When you use it, you have to verify all data before modifications. One person told me he had a great idea. In a C program, you can create a hash value for your data structures that are non-modifiable. That's an idea. Or you can define everything as private by default and then go to a less secure state as you're using it. That's important. That's more from a psychological perspective, because if we have a tendency to think, I'm going to define X as an integer. But what if you define a private value of X as an integer, and that goes with your mindset? It is easier to go from a secure state to a non-secure state than vice versa. Because if you go from a less to a more secure state, you're going to forget something. You're going to make mistakes. And if you're going to make a mistake, why don't you make a mistake on being in the more secure state? A lot of people make that error. They forget to define it that way. And when you go through your code analysis, you find you should have defined this private. Oh, sorry, let me do that. Get into the mindset of defining everything in the most restricted, most secure state known to man. It's easier to go out to a less secure state than vice versa. Again, it's a psychological issue. Think of it from that perspective. Get into that mindset. Improve yourself, because if you do that and you think that way and you get into that routine and you go to your new company and you say, I have been able to have less vulnerabilities than my other coworkers because that is the way I think, and I can show it with fewer defects, with fewer problems, your new boss, your future boss, is going to like that. They see that and they see that and they like that. Just being very ambitious. Oh yes, I write secure code. No, you don't. If you can't tell me what type of work you do in writing secure code, you're not writing secure code. You should be able to have metrics with that. You should be able to show something. I had the least amount of awards from IBM because I was always the slowest, but I was always I also had the fewest number of defects per line of code. And I'm sorry if I sound like I'm boasting myself. There were people who won huge awards for all these new features, but it broke so easily. I had the minimum amount of features, but I also had the least amount of defects. So, I mean, think about it like that. You may write a chunk of code that your boss doesn't see it a big deal. But that code you wrote may mean the difference between successful implementation and getting sued for $10 million because you did something stupid. People, unfortunately, don't get rewarded that way. But if you want to be a secure software developer, you've got to think with that mindset. You can write secure code that's flexible enough that will bend over time and be adjustable while maintaining a secure state. In the deletion part, it's most of the same as creation. You don't have to do everything the same, but what we used to be able to do, and this was even with the old kernel debugger, you would free some memory, and this is even with Java. You free some memory and the Java garbage collection kicks in. Sure, I can probably find a way to bypass it. But you need to make your due diligence effort in order to implement it. You can't be perfect. But regulators are not looking for perfection. They're looking for due diligence. And if you're the manager of a company and you're not promoting this with your employees, you're not a manager. You suck. I'm serious, you do. Because I had many arguments with bosses. They just wanted it now. They wanted it immediate. They didn't care about anything else. We'll fix it later. I guarantee if later never comes. Do it now. You must control the data at all times. You own it. You must maintain a secure state. Once it's out of your control, it better be gone, because I will find it. So why are you doing with standards? I like this page, and I added this because think about what is on there. Once customers use your code, they're in. Now, Apple has a lot of clout. They can change environments, they can make a lot of changes, and you just bend with it. That's what Apple has the clout. Your product may not have that much clout. So if you're going to make changes, can your customers react to it? You may be more secure, but if it breaks your customers, I don't even care who you are. Your manager is not going to want to release a product that breaks customers. They want something that works. They want to offer a solution. Customers may be a little understanding of you, but if you are too inflexible or you don't adjust properly and it causes too much impact on their end, they're going to just drop you and go to your competitor. Great, you're secure, but they're using your competitor. You're an unemployed secure developer, but you're still secure. Changing products will be expensive. So what are you doing from the very beginning? Don't think that you can think about, I'll design flexibility later. It won't happen. For those of you who think it's going to happen, it won't. Okay? So one common area in looking for flexibility is through the static code analysis. Now, what I usually do when I'm looking at a static code, I never like the idea of giving an end user the ability to access data directly. It's always through an interface. Like, for example, in the 1980s, the drinking age in many states in the country was 18. Okay, eventually it was bumped up to 21. You own the code that confirms if you're within a valid range to drink. So if you give your customer the direct ability to read what's in your data structure or variable, and he can change that, now that impacts you. But if you work through an interface, you can just bump up if it's less than 18, or you can go up to less than 21. Much simpler, and it doesn't impact your customer. Of course, your customer will have to do a little bit of reasonable development on his or her end, but at least you're doing your due diligence. Think of the change. And again, I've worked with PCI enough, and what used to work great in PCI doesn't work great anymore. The companies that survive the change with PCI are the ones that roll with the new changes of PCI. Don't be so inflexible that when PCI makes a change, you're scrambling to fix what's inside your code. Okay? Now, I mentioned about, yes, I'm still going to go into code analysis. Now, one of the problems with static code analysis is you can miss something like heartbleed or shell shock. A lot of code analysts just miss that. Remember, older versions of encryption work, but newer versions didn't. Another problem with static code analysis is that you can look at a problem from an immediate perspective and say, yes, this is good, or no, this isn't. But if you're doing interactive evaluations over time, how do you know when you started here is going to get over here? You've got to keep that in mind too, so you need to understand the big picture. Static code analysis tends to be more small, but it's still very useful because you can at least identify immediate problems and correct them before they're released. Now, in the area to make yourself more flexible, oh wow, I forgot. Okay, you got to be more modular. You have to think about modularity, encapsulation. Create a component, sort of a black box, if you will, that does a certain function. Test the hell out of it, make sure it works, and then move on. This is more like the agile software development rather than the waterfall development method. I hate people who don't document, and nobody seems to do that anymore. I want to know why you did it the way you did. And I beat people up all the time for failing to document. If you have to have a dependency or you have to have a limitation and you don't explain why, your code sucks. But you may have a valid reason why you had to be limited or you had a dependency. If you give me an explanation, I can understand why. But if you don't explain it, and I will not permit any static code analysis without proper documentation. I don't need you to write a book, but I want you to understand, I want to know why you did what you did. And in every static code analysis I've ever done, every type of code review, and they hate me for this. They don't think documentation is needed anymore. In the old days, we had to document very well. You had to understand what you were doing, and you had to make sure that the person who's going to take over your position understood it as well. Okay? And again, any data that is public or protected is be considered untrusted. You must verify at all times. Now, going into the modularity perspective, what I like to do is I have the critical functionality in here, and then I have sort of like a buffer. Because when you change it over time from one to another, it's easier. You're still doing this in core process, but if you're more flexible to your customers' needs and to regulatory needs, at least it gives your customers and gives them a little bit, they have to do less work. It's easier on you. It's easier on your coder overall. There may be a case where you might have to deal with characters that might be an impact in your database, as this cartoon says. D'Alessandro is a legitimate last name. My sister's friend was last name D'Alessandro. But if you have to move it over to a database environment or have somebody read it from your buffer, are you giving him the opportunity to transfer these characters to something that's more satisfactory to that person's perspective? So you need to have cross-functional teams. That's why you need to get your database people in. You need to get other people in your team so that you know what they need so you can provide it to them. Because if they have to make the change, more or less they're going to do a poor job. And I'm not going to go into this example because we don't have a lot of time. But the example on the top is some more the way I like to do it. Because if you change undefined age, that can be an uninitialized value. -1 can be an undefined value, or an undefined age. In this case, you can use the current status in this code, but what if undefined age is changed? Will it work in this environment? Maybe, maybe not. This may be a little larger, but it's a little bit safer, and it's a little bit easier to change if you're forced to change your values for some reason. Okay? In modular and flexible code development, you need to focus more on the agile methodology. The waterfall method, you can use it, but it's complex and it's hard because you've got to make small iterative changes over time. You've got to think of it from a class perspective, or if you're doing a non-object oriented, you've got to think of it from a component perspective. If you want to learn how to do good software development, read NASA's documentations on software. Seriously. They really take software development seriously. Okay? So I am out of time, and I know I've got to give, but I will make one more thing. Career, this not only helps you in your development, think about it from your career perspective. I guarantee if you come back 5 years from now, you'll probably change jobs. Be the person who is more, provides more metrics, who provides more flexibility, who is more aware of the long-term development, and you will do better in your career. You're welcome to welcome to connect with me. Are there any questions? And thank you very much.
Thank you for attending. Thank you, Larry. Thank you for your time.